All right, welcome back, guys. We got a lab that I'm going to do here today. As you can see, we got the setup, car, and ramp. We're going to take some position time data. It's right here. Mr. Jack-o'-lantern is right here. Let's get started. So first thing I'm going to do is I'm going to set up these photogates. These photogates will time in between the two photogates. When it hits this one, it'll start. When it hits the next one, it'll stop. So what I'm going to do is I'm going to set up at different positions along the way and get the time it takes to get to that position as this car here rolls down the ramp. All right, this is going to give us an accelerated motion, or in other words, as the car goes down the ramp, it's going to speed up. All right, we know that. We know that this is faster. You can even listen to it and hear it. You can hear it get faster as it goes to the bottom. We're going to take some data. I'm going to put it in the table, and then I'm going to let you guys graph it and see what we come up with. Here we go. First one, I've got set at 10 centimeters, excuse me, 10 centimeters, and we're going to see what that time is, and we'll fill it in. Here we go. Boom, so for 10 centimeters, I have 0.2691. There we are. Now I'm going to move this down to 20 centimeters. 20 centimeters, and we'll see what we got there. Reset the Photogate. Time it. I got 0.4516. See if you can, as you're watching me do this, if you can detect a pattern. All right, now I'm going to move it down to 30. Excuse me. We'll get a time of 0.5848. All right, and we'll go to 40 centimeters. Now, you guys can't see it, but I've got this set up. If you notice, at the beginning, it doesn't go up. And what it does is it detects the time when it hits this little tab here. So I can't put it all the way up at the top at 0. So I've actually got it offset by about 3 centimeters, but it still works. Let's get our number for 40 right here. With 7012, and we'll go to 50. We've just got a couple more left to do. 0.8163. Now notice these times are a lot smaller, and this gives me 4 decimal places, so I'm going to use all of it. That's very important when recording numbers. When we're doing it off of a digital device, we include all of the numbers. If we were doing an analog, we would actually have to add a number, the in-between, if you've ever looked at a ruler and the in-between hash marks. We'll get to that if we need to, but if you get an electronic device that gives you numbers, the appropriate thing to do is to write down all of them. That's the accuracy of the device, or of the reading, so we'll write down all of them. 0.9148. All right, and then we'll get the time to reach 70 centimeters. Is that our last one? No, we got to go all the way to 80. I don't know if I'm going to be able to get the last one. 9994. All right, and then 80. Oh, I got these all mixed up. But I'll rearrange them to line up in just a second. Oh, we'll go to 80. I think I got just enough room here to get all the way down to 80. Yeah, just enough. So that should be good. Let's see if we get 10961. All right, those are the numbers. Let me adjust this over here, and we'll so that they line up. 20, 30 centimeters, 40 centimeters, 50, 60, 70, and finally at 80. All right, so there's your data that you're going to plug in. Let's get a little bit of a close-up to that. I'll put in a photo of it so that you guys can take a look at it if you can't quite see what's on the whiteboard right now. All right, that's going to do it. You guys are going to graph this accelerated motion, and we're going to have a see what kind of patterns you get, and I'll ask you some questions as we go.